This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the product rule. So I want to start with looking at the derivative of x plus 1 times x plus 5. Many students would like to just multiply the derivatives. Well, the derivative of x plus 1 is 1, the derivative of x plus 5 is 1. If you multiply 1 times 1, you get 1, and that is not the derivative of this function. It'll be easy for us to see. So if we have two things multiplying, you do not simply multiply the derivatives. It is a more complex process. Well, let's see why the derivative of this is not 1. If we multiply those pieces out, x times x is x squared, x times 5 is 5x, 1 times x is 1x, 1 times 5 is 5, so we get x squared plus 6x plus 5. The derivative of the sum is the sum of the derivatives, derivative of x squared plus derivative of 6x plus derivative of 5. Derivative of x squared is 2x, derivative of 6x is 6, derivative of 5 is 0. So we get 2x plus 6, which is not the derivative of this, 1 times the derivative of that, 1. 1 times 1 is not the derivative. How do I get 2x plus 6 from that kind of problem? Well, to answer that, we have to look at the product rule. So here is the way it is usually stated in textbooks. The derivative of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. I prefer to use u's and v's instead. So when I do these problems, I like to think the derivative of u and v are both thought of as functions of x. Derivative of u times v is u prime v plus uv prime. So as I do these things, I will be defining u and v to determine what the derivative of the product will be. So let's take a second look at this problem where we saw the derivative was what? We saw the derivative was 2x plus 6. So let's see if the product rule can give us that. I need to define u and I need to define v. So I'll say u is x plus 1 and I'll say v is x plus 5. U prime, the derivative of x plus 1, it's the slope of x plus 1, it's just 1. V prime, the derivative of x plus 5, also just 1. So to use the product rule, it's u prime v plus uv prime. U prime v, 1 times x plus 5 plus x plus 1 times 1. U prime is 1, v is x plus 5, so this times this, plus u is x plus 1, v prime is 1. Now you'll notice what that becomes, just x plus 5 plus x plus 1, which is 2x plus 6. And that agrees with what we had before. So when you have a product of two functions, you must take the derivative of the first times the second plus the first times the derivative of the second. It is not as simple as just multiplying the derivatives. That's the point we're trying to make here. So if I have 3x squared plus 1 times 7x plus 5, I could multiply all this out and then take the derivatives, but I want to go ahead and demonstrate the product rule. So u will be the first piece, v will be the second piece. U is 3x squared plus 1, v is 7x plus 5. U prime, the derivative of 3x squared, 3 times 2x. U prime is 6x. The derivative of 7x plus 5, remember a derivative is a slope, mx plus b, the slope here is 7. So to find the derivative of this product, it'll be u prime v plus uv prime. U prime v, 6x times 7x plus 5, plus u, 3x squared plus 1 times 7. Again, u prime 6x, v 7x plus 5, plus uv prime 3x squared plus 1 times 7. Distributing, 6x times 7x is 42x squared, 6x times 5 is 30, 3x squared times 7 is 21x squared, 1 times 7 is 7. And then we have some like terms here. What do we have? 42x squared and 21x squared would give me 63x squared. The remaining pieces are 30x plus 7. And again, the derivative of this first piece is 6x, the derivative of this piece is 7, but you do a whole lot more than just multiplying the derivatives. You have to use u prime v plus uv prime. Our next example is the derivative of 5x to the fourth times e to the x. U will be 5x to the fourth, v will be e to the x. We know we need u prime v plus uv prime. If u is 5x to the fourth and v is e to the x, what is u prime? 5 times the power rule, x to the n and x to the n minus 1, 4x cubed. 5 times 4x cubed is 20x cubed. V prime, the derivative of e to the x, is e to the x. So to find the derivative of the product, I've got to go u prime v plus uv prime. U prime v, 20x cubed times e to the x, plus uv prime, 5x to the fourth times e to the x. And that answer is perfectly acceptable. To match textbook solutions, though, you're probably going to need to factor out the common pieces. And each one of these pieces has a 5, because 20 and 5 both have a common factor of 5, have an x cubed, because x cubed and x to the fourth each have a common factor of x cubed, and an e to the x. So if I'm going to factor this out, I will factor out 5x cubed e to the x. All that's left here is 4. Notice 5 times 4 is 20, x cubed e to the x. But here I have an extra x. So when I divide 5 by 5, I get 1. X to the fourth divided by x cubed, I get x. E to the x divided by e to the x, I get 1. So if you want to factor it out, the final answer would be 5x cubed e to the x times 4 plus x. Our next example is the derivative of 6x squared times the natural log of x. U is going to be 6x squared. V is going to be the natural log of x. Now the derivative of 6x squared, 6 times the derivative of x squared, 6 times 2x, 12x. U prime is 12x. If v is the natural log of x, recall that the derivative of the natural log of x is 1 over x. So I have u, v, u prime, v prime. I have to use my product rule, which is u prime v plus uv prime. U prime v will be 12x times natural log of x plus uv prime plus 6x squared times 1 over x. And you'll recognize that 6x squared times 1 over x will just yield 6x. And then we'll have an x divide out on the top and the bottom. And that our final answer will be 12x times the natural log of x plus 6x. For our next example, I have the derivative of 3x times e to the x times natural log of x. Now, one could develop a formula for the product rule for 3 pieces, but I just prefer to use the product rule twice. I'm going to let u equal 3x e to the x and v equal natural log of x. Now v prime is easy. The derivative of natural log x is just 1 over x. We get that fairly quickly. But to get u prime, I have to use the product rule again. So I will say capital U is 3x and capital V is e to the x. And then we'll go ahead and do the product rule one more time to find out what this derivative of this little u is going to be. So how did that go? Again, capital U is 3x from up here. Capital V is e to the x up there. Capital U prime, the derivative of 3x is 3. Capital V prime, the derivative of v is e to the x. Derivative of e to the x is e to the x. So our rule is u prime v plus uv prime. U prime v, 3e to the x plus uv prime plus 3x e to the x. So this is the derivative of this piece. So I'm going to replace little u prime up here will be 3e to the x plus 3x e to the x. Now I have successfully worked with the lowercase symbols. There's little u, there's little v, there's little u prime, there's little v prime. So our final answer will be u prime v plus uv prime. That's what we're going to need to do. So let's take a look at that algebra and see how that works out. U prime v, in parentheses, 3e to the x plus 3x e to the x in parentheses times natural log x. That's what we'll need for our u prime v. And our uv prime will be 3x e to the x times 1 over x. There's your parentheses, 3e to the x plus 3x times e to the x times log x, u prime v, plus uv prime, 3x e to the x times 1 over x. Now how does this simplify? We can distribute the log x here, 3e to the x times log x. Distribute the log x here, 3x e to the x times log x. And over on this piece, 3x times e to the x times 1 over x, you'll notice we can get an x to divide out. This is a factor since it's a multiplication between them. This x and this x will divide out of the top and bottom. So after we distribute, we see 3e to the x log x, check, plus 3x e to the x log x, check, plus 3e to the x with the x dividing out on the top and the bottom. So that indeed is our final answer. So with 3 functions, our original was 3x e to the x times log x. My strategy was to let these first two guys be little u, and then go through the process with capital U and V to find the derivative of that to get our final answer. And that will conclude this lesson.